A quasar, short for quasi-stellar radio source, is an extremely energetic and luminous astronomical object found at the centers of some galaxies. Quasars are characterized by their intense radiation across the electromagnetic spectrum, from radio waves to X-rays. They are among the most powerful and distant objects in the universe. Here's an overview of what a quasar is and how it emits intense radiation. Characteristics of quasars. Distant light sources. Quasars are extremely distant celestial objects, often observed at cosmological distances. The light from quasars takes billions of years to reach us, allowing astronomers to study the universe's early epochs. Compact and extremely luminous. Quasars are compact objects, yet they emit prodigious amounts of energy, outshining entire galaxies. Some quasars can be more than 1,000 times brighter than their host galaxies. Black hole at the core. The central region of a quasar is believed to harbor a supermassive black hole, with a mass ranging from millions to billions of times that of the Sun. This black hole is surrounded by an accretion disk, a swirling mass of gas and dust spiraling into the black hole. Mechanism of intense radiation emission. The intense radiation emitted by quasars is primarily attributed to the accretion of material onto the supermassive black hole at their core. The process involves several key steps. Accretion disk. As gas and dust from the surrounding galaxy fall toward the central black hole, they form an accretion disk, a flattened, rotating structure around the black hole. The gravitational forces cause the material in the disk to heat up to extremely high temperatures. Friction and heating. The material in the accretion disk experiences strong gravitational forces and undergoes immense friction as it spirals inward. This frictional heating results in the emission of intense radiation across the electromagnetic spectrum. Jets and relativistic effects. Some quasars exhibit powerful jets of high-speed particles that are ejected from the vicinity of the black hole. These jets produce additional radiation, and their relativistic effects contribute to the overall observed characteristics of quasars. Doppler shift. The high velocities of the material in the accretion disk and jets cause significant Doppler shifts in the emitted radiation. This effect leads to observed spectral lines that are broadened and shifted, providing insights into the speeds and dynamics of the material. Emission lines. Quasars display characteristic emission lines in their spectra, which are produced as the intense radiation interacts with the surrounding gas. These lines serve as diagnostic tools for studying the physical properties of quasar environments. Lyman alpha forest. Quasar spectra often exhibit a series of absorption lines known as the Lyman alpha forest. These lines result from the absorption of quasar light by intervening neutral hydrogen gas clouds along the line of sight, providing information about the distribution of matter in the early universe. In summary, quasars emit intense radiation primarily due to the accretion of material onto supermassive black holes at their cores. The processes of accretion, frictional heating in the accretion disk, and the presence of high-speed jets contribute to the extraordinary luminosity observed in quasars. Studying quasars provides valuable insights into the early universe, the dynamics of galaxies, and the behavior of supermassive black holes.